Alright, good day everyone. We welcome back to our class, Chem Easy International. Without wasting any of our time, the topic we are going to be doing justice to today is particulate nature of matter. Particulate nature of matter. Just like we've known before now, that matter is anything that has mass and occupies space. These matters have their properties, the way they behave. In fact, at this point in time, before the end of this class today, we should be able to understand how matter behave in a particulate manner. We should be able to understand atoms, molecules, ions, atomicity, Dalton's atomic theory, the modification done to Dalton's atomic theory, and then atomic structure. Now, particulate nature of matter is an idea brought forward to explain that matter, in whatever states, in whatever form, behaves as particles. To demonstrate that this is ammonia solution and this is hydrochloric acid. Alright? According to particulate nature, the content of this guy is matter, hydrochloric acid. The content of this guy is matter, ammonia, because it has mass and it occupies space. Now, according to the idea, if the content actually is particulate in nature, that is, it contains elements that are in bits. When we say particles, we mean building blocks, bit by bit, that are in constant motion. If truly this guy contains particles that are always in constant motion, and this guy also contains particles that are always in constant motion, and there is a tendency to react hydrochloric acid with ammonia to form ammonium chloride. Then, if I open this guy, and then I open this, as you can see, I should be able to see a reaction going on between them. This reaction is basically as a result of the movements of the particles in this hydrochloric acid and the movements of the particles in this ammonia coming together and forming a reaction. So I think this is a perfect example in demonstrating what particulate nature of matter is. Atoms, just from what we know before, that atoms are the smallest particle of an element, the smallest indivisible particles of an element. This simply means, according to Dalton's atomic theory, the theory that basically explains atoms, although there are some limitations. Apart from Dalton's atomic theory, we have Thomson, J.J. Thomson, Ernest Rutherford, Niels Bohr. All of these theories are interested in explaining the behavior of atoms. With respect to the content of this class, Dalton's atomic theory, there are just 4 of them, which I codified as paste. Alright? As paste. P for particles, A for atoms, C for combination, and E for equal. Dalton's atomic theory number 1, which is P, states that elements or matters are made up of small indivisible particles. Particles, like the letter P from the paste. Alright? So, Dalton's atomic theory, like I said, are codified into this word, probably because John Dalton in 1808 is somebody who is pace. You know what you say? We set the pace. He's the first person to set the pace as far as atomic theory is concerned. So in 1808, he proposed 4 of these theories. Number 1, which is elements or matter, is made of particles, small, indivisible particles. Alright? Alright?
Yes.
This is what the P stands for. Alright?
Yes.
A is that they are alike. Alike. That simply means that atoms,
Of the
this is
same
called
atoms.
atoms. Right?
Yes, so
A means that atoms
of the same
elements
are
are
like.
alike. That is A.
Yes.
And then we have the C, which means combine. Alright? That simply means that atoms combine
to form molecules.
in simple
Ratio.
whole numbers. Alright? That means atoms combine in simple whole numbers. Now, the fourth one, according to John Dalton, is that they can neither be created, alright,
Not destroyed.
or not destroyed.
Yes.
Created, not
Not
destroyed.
destroyed.
Atoms, alright,
Yes.
can neither
And
be created nor destroyed. At times, for those of you that will be writing exams, probably WAEC and NECO, there are some questions that will ask you. I like the 4 Dalton's atomic theory. Since you know that John Dalton in 1808 was the first person that set the pace concerning atomic theory. So that's the word pace.
yes,
Is what abbreviates
the
the
theory
4 propositions
by that is.
of Dalton's atomic theory.
Yes.
Particles alike, right?
Yes.
Combine, can neither be created
No.
nor destroyed. Right?
Yes.
So, I've done this. Now, like I said, atoms, to enforce or to engender the understanding, to make the understanding become clearer. These are cubes of sugars. These cubes of sugars are usually in cartons. Alright? According to definitions, atoms are the smallest particle of an element. Indivisible. That simply means if I begin to crush this cube,
Yes.
I will get a bit that can never be further divided.
Indivisible.
Alright? Indivisible. This is an atom. For molecules, molecules are the smallest particles of a compound that are capable of independent existence. Alright?
Yes.
They are capable, it simply means that, this guy here, atom here, actually is the smallest indivisible particle. But it cannot exist, it doesn't make sense. This guy is meaningless. It does no work. But when you have this, you can say, okay, I have 5 cubes of sugar. I have 5 molecules of a certain compound. Do you understand?
Yeah, I understand.
So it means that a molecule is the smallest particle of a compound. Just like you in this part of the world, in Nigeria, most buildings have compounds. In the compound, you have people living within them.
Yes.
Right? So each of these guys are like individual entities that are capable of independent existence inside this compound. That is why a molecule is termed as the smallest particle of a compound capable of independent existence. Alright?
Yes.
So, molecules.
Gone.
And then ions. Ions basically are the charged particles, charged elements or group of atoms. Charged atom or group of atoms. For instance, sodium to give Na plus E minus. This guy here is an ion because it is carrying charge. Cl minus to give Cl plus E minus. This guy, this lady here is an ion because it is carrying charge,
Yes.
either positive
Or negative.
or negative. A positively, charged ion
It's called-
are called cations. Positively charged ions are called cations. Cations. Cats. Alright?
Yes.
Negatively charged ions are called anions. Negative,
Yes.
positive. So, we're done with ions, we're done with atoms, we're done with molecules. Atomicity. Atomicity. Alright?
Yes.
In each one of these guys, I have about 60 questions from, from different levels of education,
Yes.
especially high schools. About 60 questions of them from JAM, about 60 questions from them from WAEC.
Yes.
Oftentimes, you look at this topic as one of the simplest topics, but if you have the opportunity to mark students, even external exams, it's like they just completed JAM exams, you have the opportunity to sit where students are answering questions. You discover that even these topics or these subtopics throw off students, probably due to ill understanding. So atomicity, 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 atomicity. That means we are interested in atom, micity, numbers. Alright? Atomicity. We are interested in atom, molecules and their numbers. That simply means the number of atoms in one molecule of an element. The number of atoms in one molecule of an element. Alright?
Yeah.
This is what we are saying. For instance, if you want to write oxygen, you write it as O2.
Yes.
This is 1 mole of oxygen.
Yes.
Nitrogen, N2. Alright?
Yes.
Carbon dioxide, O2. That is a compound, right?
Yes.
So, if you look at this, if you want to write phosphorus, B4, sulfur, S8, sodium, in fact, all metals are monoatomic.
Yes.
Alright? Atomicity is the number of atoms per molecule
Yes.
of an element. This is 1 mole of oxygen, 1 mole of nitrogen, 1 mole of phosphorus, 1 mole of sulfur. Right?
Yes.
It means that
Okay. Thank you, ma.
it means that we can have some molecules that are monoatomic. Alright? For instance, sodium is monoatomic because one atom represents 1 mole of the sodium.
Yes.
Potassium, in fact, like I said, all metals are
Monatomic.
monoatomic.
Yes.
This guy here is diatomic.
Yes. Two atom.
This is diatomic. This is tetraatomic.
Or polyatomic.
This is polyatomic. Tetra, mono is 1.
Yes.
Di is 2. Tri is 3. Like ozone. Ozone is triatomic.
Yes.
Alright? And another chipping that I want to chip in. For those of you that will be writing WAEC or NECU, and you are asked, define atomicity. In this case, after defining, though you can count for 1 mark or 2 marks, it is advisable, or it is advised, that after the definition, you then say example, e.g., because each one of the points carries their own marks, e.g., monoatomic, diatomic, triatomic, and so on and so forth. We've done justice to Dalton's atomic theory. John Dalton, 1808, he sets the pace. Like Oyo State would always say, we set the pace
Others follow.
and hold the ace. We set the pace, others follow. Ajíṣebí Ọ̀yọ́ láàárí for the Yorubas, that you copy from Oyo State. Oyo will never copy from you. The same thing as John Dalton is copied from. All other theories are the continuation of John Dalton's theory. So it's the one that sets the pace. P, particles. A, alike. C, combine. E, D, you understand? cannot be created, CE, created nor destroyed. So atomic structure or modification of John Dalton's atomic theory. For each one of these theories, each one of these postulates, all right, we have exceptions. In fact, we have modifications. It's only the law of God, the theories of God that will continue to be without any modification. All right?
Yes.
It is only the theory of God that, in fact, even the theories of God, within those theories, God himself modified some. And that is why you will see some, irregular objects. The way God is creating human beings, 2 ears, 2 eyes. You see some that are irregular. All right? So the same thing applies to John Dalton's theories. Modifications. Each one of these theories are modified. You may be asked, list the 4 modifications of John Dalton's theory. Matter is made up of small, indivisible particles called atoms. This is modified. It is modified because it has been discovered that some particles can actually be divisible. Some atoms can actually be divisible, especially atoms like radioactive elements, radioactive atoms. They can be divided.
Yes.
They can be divided. And that is one of the limitations of John Dalton. It is unable to explain the subatomic particles. Now when when you radiate an atom, what are the subcomponents?
Yes.
John Dalton is unable to explain it. All right, like protons, electrons, and neutrons.
Yes.
So, the first modification of this first proposition is that it is not true. It is not always true, especially for what?
Radioactive elements.
Such as, for instance,
So, radium.
226, all right?
Yes.
Can be divided into radon, helium, 42 plus radon,
Radium.
all right?
Yeah, 222.
224, all right?
222.
222,
22, yes, 22. Yes.
all right?
Yes.
So, this is an exception to this. It is not always true,
Yes, yes.
especially for radioactive elements.
Elements.
The second one, atoms of the same elements
I
are
like.
alike. All right? This is an element.
Yes.
This is another element. Atoms are the ones that I break down into small indivisible particles. All right?
Okay, yes.
It is said that since they are the same elements, atoms of this guy and atoms of this guy are the same in all ramifications. That is not always true, especially for isotopes. For isotopes, they are the same elements, but their atoms are the same, have different properties. For instance, I give you chlorine. That is the second modification. Atoms of the same elements
are alike.
are alike. Are alike. Alright?
Yes.
Remember this sugar. The cube of this sugar, the atoms of this sugar, and the atoms of this other sugar should be alike in all proportions.
Yes.
However,
Except
on a deeper look, it was discovered that there is an exception. It is not always true. It is not always true.
Right.
You may want to give example. Chlorine. We have the ones of 35 and the ones of 37.
Yes.
Even though they have the same proton, but they have different neutrons. They have different
Neutron.
number of neutrons.
Yes.
In fact, another example is carbon 13 and carbon 12.
Yes.
Even though they have the same
Proton,
but different mass number. And that leads us to what they call isotopy. Isotopy. Isotopy is the phenomenon, the existence, the occurrence of atoms of the same elements having the same atomic number but different mass number. Usually when we come to symbols, valences, you understand? I'm going to do justice to this in furtherance of our explanation. always, all right, atomic number is usually, this is the symbol of the elements, all right. I'm going to drop a link to this video where I give abbreviations on how you can memorize the first 50 elements. So usually this is represented as the symbol for the elements, and beneath here as a subscript, it is called the atomic number, and the superscript, you have the mass number. So isotopes, then we talk about isotopy, this phenomenon, the occurrence, the reality, the happening, all right? But isotopes are those atoms themselves, the atoms of the same elements that have the same atomic number but different mass number. These guys are isotopes. These guys are isotopes. The property, the phenomenon is called isotopy, but these are isotopes. So that is the second modification. The third modification, atoms combined in simple whole number ratios. It is not always like that. What that simply means is that, for instance, all right, N2O, this is 2 atoms of nitrogen, 1 atom of oxygen. This is nitrogen peroxide. No. This is dinitrogen 1 oxide. Dinitrogen 1 oxide. All right. If you are having, this is 1 mole. If you are having 2 moles of this, it is still going to be N2O. All right. In simple whole number ratio, that is 2 to 1.
Yes.
All right. No matter the number of molecules that you're having, but this is not always true. It may be true for inorganic molecules. It is not always true for organic compounds. For instance, this is methane, all right, CH4, all right, C2H6, all right.
Yes.
If we are gonna go by ratio, let me go again, C3H8.
Yes.
So I'm gonna go by ratio. These guys belong to the same homologous series.
Yeah.
They are the same family, right? But if you are going to go by the ratio, it's supposed to be C1H4. That is to say, for each atom of carbon, we should have 4 atoms of hydrogen. If we are going to go by this law, by this theory, it means the second member has to be C2H8. It doesn't work. Meanwhile, the second member is C2H6. So it is not always true that atoms combine in simple whole number ratios. It is not always true, right?
Yes.
This is the third modification. The fourth modification, atoms can neither be created nor destroyed. This is also not true. From the first explanation that I tell you, for the radioactive elements, you can produce, we are generating this from this. It's more or less that we are destroying this and creating this. So it is not always true, right? And Yorubas would say, if you have juju, it is where your own juju ends that another person's juju starts. That simply means that if you come forward to explain an occurrence, to explain a phenomenon, somebody will come sometimes again and tell you that those phenomena have, holds no water any longer. They have exhausted their lifespan. So these are the propositions of Dalton. And then, like I said, they are all modified. Lastly, for this class, it's going to be atomic structure. Atomic structure. All right? From the word structure, each of, before you have a house, you have pillars.
Yes.
Before you have pillars, you have foundation.
Yes.
Before you have foundation, you have sands.
Yes.
Before you have sands, you have pebbles. You have cement. Before those are the things that form a structure, a building. All right, the bit by bit, atomic structure, the structures of atoms. All right, the way atoms are built. All right, the composition of atoms. In biology, they will tell you gamete plus gamete gives zygote. What are the things that are composed of each and every atom? You know, probably in this class or in any class where you are, to document anything you need what? You need a pen. That pen represents the components of all atoms at this level anyway. Even though those structures, those components can also be further divided. But for this level, we have just 3 of them. And those 3, like I usually do in my classes, you know, I give you shortcuts to understanding concepts. Alright?
Yes.
Those 3 things are the pen, P-E-N. The P-E-N are the 3 components of atoms that make up the structure of atoms. We have the proton, we have the electron, we have the neutron.
Yes.
To the best of your knowledge, you have to know about their properties, their charges, where they can be found, and their sizes, what they represent. So I'm going to start with proton. Proton, 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 PPP, positive. So the charge of proton, you know, like I said, B-E-N. We're going to talk about their charge. Alright? We're going to talk about their functions, what they do. We're going to talk about their location, where they can be found. And we're going to talk about their mass or size. Alright? P, positive. To know. Go and know forever and ever. Proton is always
Positive.
Proton is always what?
Positive.
Positive. Electron is always what? Electron is always negative. Neutron, neutral. Neutral is of no charge. The functions, alright? Elements in the periodic table have atomic numbers. Atomic numbers are the products or are the direct representation of the number of protons. An element with 1 proton has atomic number 1.
Yes.
An element with 2 protons, atomic number 2. The proton is the atomic number. Proton, atomic number. Just like saying that how old you are depends on how much of proton that you have. If you have 1 proton, you are 1 year old. You have 2 protons, you are 2 year old. You have 3 protons, you are 3 year old. So an element, an atom that has 1 proton is having 1 atomic number 1, hydrogen. So this gives us the atomic number and most times the physical properties. The electron gives us the electronic interaction.
Okay.
Alright?
Yes.
It tells us in what form will the atom combine. How will the atom combine?
To form,
Right?
yes.
For instance, that's where you get to electronic configuration. Electrons are used for electronic configuration. When we get there, we are going to further demystify it. Alright?
Yes.
Neutron, they represent the mass. That's their function. Right? The mass number. In fact, not only neutron, even proton tells you about the mass number. Alright? The mass number of any element, of any atom, is the addition of the proton and the neutron number.
Yes.
Right?
Yeah.
The mass number. How heavy an atom is a function of adding the proton and the neutron. Then we have the location. Alright, like I said, there are many propositions, many theories, many explanations that have been put forward to explain the way atoms are. Alright?
Yes.
But in this case, to explain the location, the most important one, anyway, for this level, from those 4 theories, is from Niels Bohr. Even though Niels Bohr was unable to explain more than atomic number 1, element that has only 1 electron, alright, because he was unable to tell us the force that is keeping the electron revolving in the shell. Or he was able to tell us that no, alright, electrons are revolving around the shell. So the location The proton can be found in the nucleus. Electron revolves around the shell in the nucleus. Alright?
Yes.
And that is why I give you another example. If you go to where they sell RAM,
Yes.
the part that will determine how heavy the RAM is the inner part. How big? Like a cow. What will determine this, the weight of the cow is how big the stomach is. So that stomach is where the nucleus is where you can find, atoms are said to be in this shape. Alright?
Yes.
Within it, you have the nucleus. Revolving around it is the shell. This inside part, nucleus is always the inner part, is where the weight concentrates on. Alright, like I said in cows, the place where even in human beings, they'll tell you that it is the person that has stomach, big stomach, that you should give money. That is where the money is. This is where the determinant is of how heavy this guy will be. Alright?
Yes.
So the determinants, there are two things inside, which are the proton and the neutron. So the location of this proton
Yes.
nucleus, the location of this neutron nucleus. And that is why when they ask you the nucleon number, nucleon is from the nucleus, from the word nucleus. It's the same thing as the mass number. That means you are going to add the number of proton and the number of neutron together. That is the mass number. The atomic number is just the proton. This guy, electron, it revolves around the shell. So you have to know this. Since we said the proton and the neutron determines the size, so they take atomic mass unit of 1. That is where you have AMU, atomic mass unit of 1. And because the electron is insignificant in terms of size, just like you saying that the horn of a cow, what is the significance of the horn of the cow to the size of the cow, to the weight of the cow? Or what is the significance of the eyelid of a human being to how heavy the human being is? That is the way electron is.
To the
So
atom.
it is 1 divided by 1,840. This guy, to get how much of this electron will be equivalent to this, you need about this number, 1,840.
40.
So, with the limit in time and space, of course we are going to, like I said, the class is incomplete. Even though we are giving explanation, we are still going to give you questions, all right? And I want you to follow me, all right? Step by step, all right? After the class, if you have any question, addition, elimination, substitution, please feel free to add it in the comment section. After this class, there's another class whereby we're going to look at questions that are related to this topic. Just a quick recap. In this class, I've been able to explain what particulate nature of matter is. And matter behaves as particles. I demonstrated it with ammonia and HCl. In fact, another way to demonstrate it, look at this. This is water. If you should shake your water, you will see that there are some things that are moving. They are moving. These are the particles, the small bits of the water. In fact, the movement, because you can see in some other questions, is termed Brownian motion. Particles of matter are always in motion. They are always in motion. They are never static, even though the motion can be different depending on the state of the matter, whether the matter is in solid states, liquid states, gaseous states. The gaseous state is the most, the fastest, the zigzag manner, all right? So we are going to see questions in this manner. Are we there?
Yes.
We've also explained atoms. I demonstrated it with sugar. We explained molecules, sugar, the smallest particle of a compound that is capable of independent existence. This is capable of independent, unlike just, you know,
Please.
what do you call it? A pebble or whatever, a grain
Yes.
of sugar. This is not capable of independent existence. I hope you understand.
Yes.
What about ions? Ions are usually charged. Either an atom that is charged or a group of atoms that are charged. That reminds me, just a quick one. Because of time and space. A group of atoms, for instance, SO4, 2 minus. Of course, when we come to valency, we talk about how we come about this. This is also an ion. This is also an ion, and so on and so forth. Of course, it is a charged group of atoms. All right.
Yes.
When we get there, we will discuss for the atomicity, the number, you know, of atoms in one molecule of what? Of an element or a compound. All right.
Yes.
Dalton's atomic theory. John Dalton sets the pace. So pace, P, particles, A, alike, C, combined, CED, created, nor destroyed. So the modification and then atomic structure. So please, if you have any comments, so that this video will not be too huge. There are more and more explanations. There are more and more, you know, live examples. There are more and more and more and more to explain. But for this general class, I'm going to be limiting the explanation. If you want a personal class for your children, feel free to contact me. Thank you for listening.